Hello, I'm Nick Erickson, and I'm here to talk about my joint work with David Salinas on TabRepo, a large-scale repository of tabular model evaluations and its AutoML applications. Everything you can find in this work, or everything you can see in this work, can be found on github.com/autoglon/tabrepo. So, AutoGlon achieves strong results without hyperparameter optimization. By default, AutoGlon trains 13 models with fixed hyperparameters. Does hyperparameters optimization help? Yes, but it's often better to spend time on other things such as cross-validation and stacking. Can we do better? So, TabRepo is pre-computed results for tabular ML. We save validation and test set predictions for 200 OpenML datasets with three folds each on 11 model families for 1,530 random bagged model configurations per cast for a total of 7.75 million fitted models, or 1310 models in the paper. We added some more afterwards. And with 1 hour fit time for each model. It also contains results on all datasets for 6 AutoML systems, including AutoGlon, Light AutoML, AutoScikit-learn 2 and 1, H2O AutoML, and FLAML. And it allows us to query a given model results on a given dataset or task um, basically immediately. We don't have to refit the model. We just know this information, and we also know the prediction probabilities and the predictions. So with this, we're able to calculate the normalized error of a variety of different things. For example, for each model family, we can calculate the result for the default configuration as well as the tuned configuration, and even ensembling models within a family together. We can also show the AutoML system results and see that no single model family is able to outperform AutoML systems, even when ensembled. Um, then we can also see the importance of each model hyperparameter. And so with TabRepo, we can do ensemble simulation. So basically, we can take the validation prediction probabilities and fit a weighted ensemble such as Caruana and Tall ensemble selection, and then calculate the test score using the test prediction probabilities. Because we can just query these prediction probabilities and we don't need to actually refit the models, this is blazingly fast. And we'll see that basically we can use these pre-computed results to find good model portfolios. And we can have a training time reduced from days to seconds with greater than 10,000 times speed up. We avoid overfitting by a 200-fold cross-validation, and the portfolio outperforms AutoGluon even with its stacking component, as can be seen here. We can also do in-depth ablation studies. As we can see, the blue lines are with a portfolio without ensembling, and the orange is with ensembling. And we can see that variety of different ablations, we're able to find portfolios that can strongly outperform all AutoML systems, including AutoGluon. And this can be done very quickly and without much extra compute requirement because we're just querying pre-computed results rather than having to train more models again. We also show here the model family presence in the portfolio by the training order as well as the relative frequency. As you can see, basically each model starts to even out at a certain percentage of the portfolio, showing the diversity that it adds and the strength that it adds to the portfolio. And we show extremely strong results, basically improvements from TabRepo. Basically, TabRepo was incorporated into AutoGluon 1.0 by taking the TabRepo portfolio and adding it as the default in AutoGluon, which led to a strong improvement in, say, the average rank in the 2024 AutoML benchmark. And I will also just quickly mention that the improvement in 1.0 is not fully from TabRepo, but I would say about 60-70% of the improvement is TabRepo. In terms of accuracy versus inference throughput, we can see that AutoGluon 1.0 strongly improves upon the existing frameworks. And additionally, it strongly outperforms AutoGluon 0.8, both if you want to match inference speed, has much higher performance, and also if you want to match accuracy, at which in case it has much faster inference speed. In terms of accuracy and training time, the same story holds true. And then on Kaggle, we have 16 major ML competitions in 2024, and AutoGlon was able to achieve a top 5 finish in 15 out of 16 of these competitions. So that's AutoGlon with TabRepo's portfolio. And 13 out of the 16 competitions with podium finishes. So it turns out XGBoost is not all you need. So in 2025, we have big plans for TabRepo. I'm not going to go over the full deal, but basically we want to create the AutoML of tabular benchmarks and end the reproducibility crisis. No more new model state-of-the-art claims comparing on outdated datasets, poorly tuned baselines, and buggy abandoned code bases. We want to make it so that it is as easy as possible to compare against the very best and work together to improve AutoML systems with these results. I have a whole bunch of other things, but I'll leave it for the AutoML conference, where I'll be talking about it in the AutoGluon tutorial as well as during the poster session. See you there.